Let's solve this one. Find the number of tangents that can be drawn through the point P to the circle in the following cases. So I'll take specific cases जहाँ पे you'll be able to you'll be asked to find out what is the number of tangents that can be drawn from the point P to the circle. First question, the point P is lying in the interior of the circle. Guys, we saw previously that to draw the tangent, the point P should lie outside the circle. Okay, यहाँ पे point P is in the interior. So यहाँ से आप कोई भी line join करेंगे. Okay, that line can be extended in both the ways. Okay, or on both sides. So it will not meet the circle in one point. It will meet the circle in 2 points, right? So it won't be a tangent. Okay, इसके बारे में बात करेंगे अपन in the upcoming classes. It's called a secant, which meets the circle in 2 points. Okay. Anyway, so here we have zero tangents possible, right? Okay, now if point P lies on the circle, you can draw exactly one tangent, right? You can draw a tangent passing through point P, something like this. Okay, not like this actually, something just like this. Okay, Coldplay and Chainsmokers, if you know the song. Okay, so you can draw a tangent from point P like this. Okay, and point P is that only one point is a tangent pass hoga, so we can draw exactly one tangent, right? Okay, now this point P lies in the exterior. Okay, like the previous case we saw. यहाँ पे you can draw two possible tangents like this. So यहाँ पे I have two tangents. Okay. So remember, guys, to draw a tangent or to draw two tangents from one point to the circle, the point should lie on the or lie in the exterior of the circle. It should not lie on the circle. It should not lie in the interior. Okay. We go on to the next part now, guys. In the next part, you are supposed to find out the number of common tangents that can be drawn between two circles in the following cases. First one is this. Okay. एक circle बड़ा वाला बाहर दिख रहा होगा आपको, छोटा वाला अंदर दिख रहा होगा. If you observe, guys, the tangent to the circle outside, okay, ये तो ऐसे छू के निकल जाएगा. It won't intersect the circle inside, right? Okay, same way you can draw a tangent like this, another tangent like this. Okay, not like this actually. Yeah, like this. Yes. Okay, like this. Okay. So you draw a tangent to the outside circle. It won't intersect the tangent. It won't be a tangent to the circle inside. Same way, if you draw a tangent to the circle inside, it will be a secant to the circle outside. Right? It will meet the circle in 2 points. Okay. Secants के बारे में बात करेंगे, as I told you आराम से. But remember, if you draw a tangent to the circle inside, it will meet the circle outside in 2 points. So you can't draw any common tangent here, right? So the answer will be 0. Okay. We go on further. Okay, the circles intersect internally, means the smaller circle is inside the larger circle. Okay, you can draw one common tangent like this. Okay, so in this case you have one common tangent. If the circles meet each other but they are not touching each other, right? They are intersecting. Okay, guys, the difference between touching and intersecting is between this figure. Okay, the figure previously, this particular figure. Okay, where the circles touch means they are having a common tangent, and intersecting means they'll meet at 2 points. Okay, so that's the difference. So in this latter case, second case, we have two common tangents possible like this. You can see. Okay, next one, the circles do not meet. Okay, they are intersecting externally. Okay, in this case, you will have three common tangents. Okay, the black color tangents and the blue color tangents. You can see here, guys. Right? Okay, so here the black color tangents are called as a direct common tangents, and the blue color tangent is called as the transverse common tangent. So in this case, we have 2 plus 1, 3 common tangents, right? In the next case, the circles are not intersecting and they are not touching also, they are at a distance. In this case, you will have 4 common tangents. Okay, 2 direct, the black ones, and you also have 2 transverse common tangents, blue colored, right? So in this case, we have 4 common tangents. Okay, now guys, what if the circles overlap? You can see the red and the black circles now. Okay, they are lying one above the other, they are overlapping. Okay, in this case, अगर आपने एक tangent draw किया red वाले पे, automatically black वाले पे tangent होगा. Okay, same way you can draw infinite common tangents here in this case. Okay, एक tangent draw करेंगे पहले वाले पे, second वाले पे automatically will be a tangent. So in this case, you will have infinite possible tangents. Okay, two circles having centers O and P and having radii 12 and 8 units touch each other externally as shown. Okay, so this is the information we have. There are two circles having centers O and B, and they have radii equals to 12 and 8 units, and they touch each other externally as shown. Okay, so the first question is, in this case, find the length of AB. That is the first question. Now, guys, if you observe carefully, AB here is the direct common tangent. We saw this just now, right? The direct common tangent. So if you can visualize this, AB is the direct common tangent here, right? And how do you find the length of the direct common tangent? Okay, the capital R radius for the bigger circle is 12, and for the smaller circle the radius is small r, which is 8. Okay, if you observe, guys, OP is the distance of the two centers, and this will be 12 plus 8 in this case, जो कि 20 हो जाएगा. Okay, so now you can directly use the formula. Capital R is 12, small r is 8, and distance of centers is 20. Right, apply the formula. You put in the values, you get 20 square minus 12 minus 8 the whole square, 400 minus 16 is equal to root 384, right? So 384, root 384 will be 64 into 6 ka square root, 64 ka root is 8, so the answer is 8 root 6. It's as simple as that, guys. Okay, so we go on to the next question of the same lot. The next question is find the ratio of xy is to AB. Now I wanted to pause this video now and try this question out, then we'll discuss. Okay, guys. So we know that यहाँ पे the point of intersection is given, right? Let that be equal to that. Let that be given by z. Okay, z is the point where the two circles meet. Okay. Now tangent segments from external point to the circle are equal. Okay. Let's talk about the point x now. Point x say to the circle having radius O, center O. I'm drawing two tangents xa and xz both will be equal. Okay. Same way I'm drawing two tangents to the circle having center P, that is xb and xz, right? So in this case, these two tangents xa and xz both are equal, and xb and xz both are equal, right? So now if I assume the length of the tangent ax as let's say a units, okay, तो xz भी कितना हो जाएगा a units and xb भी कितना हो जाएगा a units, okay? Now guys, this diagram is pretty symmetric, right? So by symmetry you can observe that xz will be equal to zy जो कि a के बराबर हो जाएगा, right? So if you observe xy will be equal to xz plus yz, okay? xy चाहिए इस क्वेश्चन में हमें xy का रेशियो विद ab. So xy you can observe is nothing but xz plus yz, that's xy. So a plus a ये हो जाएगा 2a. Similarly guys, ab पूछा है, ab क्या हो जाएगा? ab will be ax plus bx, which are nothing but a and a. When you add them you get 2a. So guys, xy is to ab will be 2a is to 2a, which is nothing but 1 is to 1. That's the required answer. Very simple. All right guys, so with that we go on to the next question. Find the length of OE. All right, guys. To find the length of OE, what we'll do right now is we have already known that OA is 12 and PV is 8 and OP is 20. Okay, now look at the triangle. Okay, OAE. Okay, highlighted in red. You can observe it. OAE. Okay, and triangle PBE. Okay, highlighted in yellow. So these two triangles, okay, OAE and triangle PBE. Okay, these two are going to be similar triangles. Okay, we have proved that like so many times. I'll do it again. So ये angle दोनों का 90-90 रहेगा, देखो तो ये भी 90 होगा अंदर का angle. Okay, and E is the common angle. So two triangles are similar. Okay, EBP is similar to triangle EAO by the A test of similarity. Okay, for similar triangles, we know the ratio of sides is equal. So EP upon EO will be same as PB upon AO, right? The ratio of sides होगा. And EP upon EO will be 8 by 12. PB 8 होगा और OA 12 होगा, right? So ratio of EP and AO will be 2:3. But guys, what is the difference of EP and EO in this case? The difference in the ratio is 2 or 3 का difference, जो कि होता है 1 unit. Okay, but this 1 unit corresponds to 20 units, right? OP and the actual question, right? देखो OP का actual length कितना दिया है question में, जो हमने निकाला है 20 units, right? So अगर एक unit 20 के बराबर है, if 1 unit corresponds to 20 units in this case, as per the question, okay? So हमें find क्या करना, length of OE, right? OE कितना है? OE है 3 units, right? So if 1 corresponds to 20, 3 corresponds to how much? 60 units, right? That's the answer for this question. Also notice that EP जो होगा, EP guys कितना होगा? 2 units, right? 2 units किसके बराबर होगा? 40 के बराबर होगा, right? This data we'll use in the next question. Okay. Next question क्या है guys? In the region enclosed by tangents BE and CE and the smaller circle, find the radius of the largest circle that can be drawn. So they're talking about this circle here, right? Okay, now we know that PB is equal to 8 units, right? And let's assume that the radius of this largest circle is equal to R units. Okay, in the previous question हमने find किया था the length of PE as 40, and you can observe that guys यहाँ पे this length will be radius इसका 8 है और इसका 4 है, so this complete length will be 8 plus 4, right? Okay, I call these two points as T and U in this case. Okay, now applying similarity of two triangles, triangle ETU and triangle PBE. Okay, PBE you can see here in red and ETU you can see it in yellow, right? Again, these two triangles will be similar by the A test like we proved in the previous case. So ratio of the sides is same because they are similar triangles. So EP upon PB, okay, sorry, EP upon EU will be same as PB upon UT. Okay, just writing the ratio of the corresponding sides. Okay, ये तो हमें 40 पता ही है guys, PE का लेंथ हमें 40 पता ही है. अब guys पूरा EP का लेंथ 40 है, okay, and 40 में से you are removing PU, you will get the length of EU, right? जो कि हो जाएगा 40 minus R plus 8 from this. Okay, PB जो कि 8 है और TU equals to R है, right? Solving this we will get R is equal to 32 upon 6 or R equals to 16 upon 3. That is the answer for this question. The maximum radius of the given circle can be 16 divided by 3. Okay, let's go on to the last question of this lot, guys. Okay, in the region enclosed by tangents BE and CE and the smaller circle, infinite circles are drawn as shown. Okay, so they'll be drawing infinite circles like this. Okay, find the sum of all their radii. Okay, so I wanted to again pause the video and try it out and we'll discuss. Okay, so one way to solve the question is, guys, see हमें ये पता है कि OE का length is 60 units, right? तो अब हम पहले क्या करेंगे, OE में से हम पहले 12 units subtract कर देंगे. 12 units means the radius of this circle. Okay, we'll subtract 12 units. Okay, so we get rid of this circle completely. इसको हमने निकाल दिया पहले पूरा, ठीक है? So from OE we basically subtract 12 units. Okay, so what we are going to get is nothing but the length ZE. ZE will be 60 minus 12, which will be 48. Okay. So guys, if you observe carefully, this ZE, okay, as I can see, it is a dancing blue line here. Okay. This ZE is nothing but the sum of the diameters of all the circles which will be drawing. Okay. Is ZE ke across will be drawing all the circles, right? So when you take the length of ZE, ZE represents what, guys? It represents the set of all the diameters, okay, of all the circles which are drawn on the line. Okay. So हम लोग क्या करेंगे, इस ZE का पहले half कर लेते हैं, right? So sum of all the diameters is 48. Okay, if you take 48 upon 2, you get 24, the sum of all the radii. So sum of the radii of all these circles is 28. Sorry, 24, 48 upon 2, 24. Okay, but that's not the final answer. बहुत लोग गलती करते हैं 24 को आंसर मार्क करके, but that's not correct. Okay, so the final answer is when you add the 12 back. हमने ये 12 मिस किया था ना, यहाँ पे निकाल देता ना starting में, right? So we add back 12 to the given answer. 24 plus 12, the required answer will be 36. ओके ओके, अंडरस्टैंड गाइस, मैंने पहले 12 रिमूव क्यों किया, वापस ऐड क्यों किया? देखो, हमें पहले तो ये लेंथ निकालनी है ZE. फर्स्ट वी नीड टू फाइंड द लेंथ ऑफ ZE इन दिस केस. वो हम कैसे निकालेंगे? हम पूरे OE में से OZ को सब्ट्रैक्ट कर देंगे, इसलिए तब जाके हमें ये ZE का लेंथ मिलेगा, राइट गाइस? ओके, and the remaining value, okay, ZE is sum of the length of all diameters, right? So sum of the length of all radii कैसे निकालेंगे? उसका half करके. Okay, and इसमें add the length OA, that is 12 in this case, right? So you get the sum of all the radii as 36. Okay guys, another way to solve the same question very quickly is by observation. We observe that यहाँ पे whenever the circles are being formed, starting from the greatest circle, the radius is 12, then 8, then उसके बाद अगले वाले का 16 by 3 we found. Okay, what do you observe, guys? 12 by 8 is nothing but 4 cancelled. Okay, this will be 3 by 2. Okay, also 8 by 16. Okay, if you divide 8 with 16, okay, 8 cancel, you again get 3 by 2, right? So basically what you have is a geometric progression, an infinite geometric progression starting with 12, the first term, and common ratio is 2 by 3. मैंने उल्टा लिखा था 12 8 8 4. अब 8 12 का ratio 2 by 3 होगा और 16 by 3 और 8 का ratio 2 by 3 होगा, right? So it's basically an infinite geometric progression starting with 12 and the common ratio 2 by 3. Now we apply the formula A upon 1 minus R. We directly get the answer in one step, that is 36. As simple as that. Okay, guys, so we meet up in the next class where we'll continue and we'll look at some other properties of circles and see you next time then.